In today's lesson, we will be simplifying expressions with negative exponents. So before we evaluated, when we had negative exponents and we had all numbers, so 2 to the power of negative 3. But now expression means variables. So what if we have x to the power of negative 3? What do? So when we have negative exponents, remember, you just rewrite it under 1 and then you change the exponent so it is positive. So if we look here, x to the 5th, x to the 4th, x to the 3rd, x squared, and x to the 1st. There's nothing we can do with those. Those are all just simplified. But now, x to the power of 0, anything to the power of 0, even if it's a variable, still equals 1. And then we're going to apply the rule we learned, except with variables. So it's always 1 over, and then whatever you have, except with a positive exponent. So this is 1 over x positive 2, 1 over x cubed, 1 over x to the 4th power, and 1 over x to the 5th power. So remember from before that anything to the power of 0 equals 1. So no matter if it's a number or if it's a variable or even if it's something super complicated, 200x to the negative 3rd divided by y to the 17th, if that whole thing is raised to the power of 0, it all equals 1. Now remember the rule of negative exponents, a to the power of negative n. We write it as 1 over a to the power of positive n. And when we have negative exponents in expressions, our goal is always to write your final answer with positive exponents. And our goal today, when we're simplifying these expressions, our final answer must always have all positive exponents. Exponents, always positive in your final answer. No negative exponents in your final answer for today. Alright, let's take a look at our first two examples. We have a to the power of negative 8, and then 1 over a to the power of negative 8. Now our goal is to always simplify expressions so there are no negative exponents. So for this first one, we just use the rule. It's going to be 1 over a to the power of a positive 8. Now the tricky part comes is, what do we do when the negative exponent is in the denominator? I will first show a longer, complicated way of why something happens, but then there'll be a quick, easy way to just memorize what happens. So I'm going to rewrite this. Instead of as a fraction, this is also saying 1 divided by a to the power of negative 8. Which means 1 divided by, if you look over here, a to the power of negative 8 is 1 over a to the power of positive 8. And now we're dividing by a fraction, so I'm going to keep it, change it, flip it. Keep the 1, change it to multiplication, and then flip it, so it's a to the positive 8 over 1. And when you multiply and divide, you get that it just equals a to the positive 8. A to the positive 8. So I want you to compare these two scenarios. And then what I use to help remember. When you have a negative exponent, nobody likes negativity. We don't like naughty, negative kids. So, when they are negative, we have to send them to the basement and make them positive. Send them to the denominator, make them positive. And if they're negative in the basement, we have to bring them upstairs and then make them positive. So, we don't like negative exponents. You always have to move them and change them. Move them to the denominator and change them to positive, but if they're in the denominator, you have to move them to the numerator and make them positive. So in this example, we once again have a negative in the denominator. So we have to move it and change it. We never have a negative exponent in our final answer, so it's in the denominator. We're going to move it to the numerator. So y, and then change it to a positive 2. And if you move something out of the denominator, it really means like it would be over 1, but you don't need to write it. So it's just y squared. Okay, now we have x to the 5th times y to the negative 6th. So when we simplify things, we only want to worry about the negative exponents. Here, x to the 5th is a positive exponent, so we're going to just keep it as x to the 5th. If it's positive, you don't change it. Now we're multiplying by y to the negative 6, which we rewrite as 1 over y to the positive 6. And then if you multiply to the numerator, so this becomes x to the 5th over y to the positive 6. So if you look back at the original, the positive exponent stayed in the numerator, and the negative exponent went to the basement, went to the denominator, and became positive. Now we have two different variables, and they're both negative. So let's rewrite both of these with positive exponents. So a to the power of negative 2 is 1 over a squared. And b to the power of negative 4 is 1 over b to the positive 4. And we're multiplying. So when you multiply the top numbers. 1 times 1 is just 1. And then on the bottom we just have a squared times b to the 4th. And that is our final answer. We're just rewriting without negative exponents. And since they were both negative, they both went to the basement and became positive. Okay, this one we have a fraction and we have negative exponents, numbers, positive exponents. So I want you to look at everything separately. And the only thing we really need to worry about is where you have a negative exponent. Think of this as you have a 3. The 3 does not have a negative exponent, so you don't do anything with it, you leave it. And you have this x to the power of negative 2. We're going to have to do something with that. And then we have this y. But the y does not have a negative exponent, so that also stays. So the only thing we have to worry about is what do we do with this part of it. We move it and you change it. It's in the numerator, so we have to move it to the basement and make it positive. But the 3 stays where it is. The y stays where it is. But now the x, now positive to the second power, is on the bottom. And there we have it. It's simplified without any negative exponents. Okay, we've got two things that are negative in this one. Negative 3 and x to the power of negative 7. But remember, we only care about the negative exponents. The top number is negative, but it's not a negative exponent, so we don't do anything with it. So the negative 3 stays where it is, and we have to figure out what do you do when you have a negative exponent in the denominator. You need to move it and change it. So it's in the denominator, we need to move it to the numerator. The negative 3 stays in the numerator, and it becomes x to the positive 7. And when you move everything out of the denominator, technically there's still a 1, but we don't even need to write it. So it's negative 3 x to the power of positive 7. Okay, 9 to the power of 0, w to the power of a positive 8, and x to the power of negative 11. I want you to think of each of those as separate things, and they're all being multiplied together. So, what is 9 to the power of 0? Anything to the power of 0 is 1. W to the power of positive 8, if it's a positive exponent, we don't do anything with it. And then if it's a negative exponent, it would be 1 over x to the power of positive 11. So now, you multiply here, so it equals w to the power of positive 8 in the numerator, and x to the power of positive 11 in the denominator. And that is simplified with no negative exponents in your final answer. Here is our very last problem. And I just want you to think about the steps of move it and change it. If we have a negative exponent in the numerator, you move it to the denominator and make it positive. But if you have a negative exponent in the denominator, you have to move it to the numerator and make it positive. So now this becomes y to the power of positive 5 on top and x to the power of positive 3 on the bottom. And that is our final answer. And that is our last example. So good luck with the lesson. Please let me know if you have any questions.